In our final video today, we're going to look at solving quadratic equations where when we solve them, we end up with a negative under the square root. So what that's going to do is bring the complex numbers for these solutions into play. Before, when we tried to solve these equations, we would just say no real solutions. But now that we've talked about these complex numbers, we can talk about the actual solutions to these problems. And we started off with A and B, a couple of simpler ones, where we don't have to factor or complete the square or do the quadratic formula. We can just get the x squared piece by itself and then take the square root of both sides. Now, do not forget that when you do take the square root, these numbers, they're going to have two answers for most of these unless you're taking the square root of 0. The positive and the negative. So in this case, for A, the x squared is already by itself, so we can undo that squared piece by taking the square root of both sides. So what we end up with is x is equal to the square root of negative 81, and there's two of those, so it's positive and negative. Well, we know the square root of 81 is 9, but since it's the square root of negative 81, that's going to become plus or minus 9i. Now, with a quick check, and why this works, if we take positive 9i and square it, 9 squared is 81, I squared, remember that's negative 1, so 81 times negative 1 is negative 81. That's why it works. If we do the same thing with negative 9i, negative 9 squared again is 81, but then we have that I squared again, so again we get negative 81. So they both work. Okay, so now we can find actual solutions to these quadratic equations. They're just going to have an I involved. Now, in example B, first thing we want to do is get the x squared part by itself. Just this x squared, we're going to get that by itself. So we want to move the 20 and the 5. We'll move the 20 first by subtracting it. And then we'll move the 5 last by dividing by 5. So we end up with x squared is equal to negative 4. So therefore, x is equal to plus or minus the square root of negative 4. Well, we know the square root of negative 4 is, the square root of 4 is 2. But because it's the square root of negative 4, we need that I as a piece. So x is equal to plus or minus 2i. Alright, then for C and D, these are ones that now we have a b value or an x term. So we're going to look at either factoring, completing the square, or the quadratic formula. Now in this case, in C, there are no factors of positive 5 that add up to negative 4. If we look at that for just a quick second, well, the only integer factors of 5 are 1 and 5, and the only way to manipulate these to get negative 4 is to make the 5 negative and keep the 1 positive. But now when we multiply these, we get negative 5, not positive 5. So this quadratic expression is not factorable. And since A is 1 and B is even, I'm going to complete the square to solve this one. And to complete the square, we clear the constant first. And then to complete the square, we take half of 4, which is 2, and then square that. And that's the number we add to both sides. So we're going to add 4 to both sides. Now, factor the left side, factors of 4 that add to negative 4 are negative 2 and negative 2. So we end up with x minus 2 squared. And on the right side, combining those two, negative 5 plus 4, we end up with negative 1. Now we're ready to take the square root, so x minus 2 is equal to plus or minus the square root of negative 1. And square root of 1 is 1, but since it's negative, it's 1i or just I. And then our last job is to get the x by itself by adding the 2. So x is equal to 2 plus or minus I. Now, again, we have two solutions to that. 2 plus I is 1, 2 minus I is the other. Now, what this means graphically is that this parabola, the x squared minus 4x plus 5, where the y-intercept is 5, axis of symmetry is at positive 2, and so on, that parabola never crosses the x-axis because we got those imaginary solutions. Now, the last one, factors of 6 that add up to negative 1. Well, we've got 1 and 6 and 2 and 3. Again, we could take the 2 and the negative 3. However, 2 times negative 3 is not positive 6. It's negative 6. So therefore, we cannot factor this one. And since a isn't 1, I'm not going to mess with completing the square. I'm going to jump right to the quadratic formula. So x is equal to, opposite of b is 1, 2 times a is 6, plus or minus the square root, b squared is 1, minus 4 times a times c, all over 2 times a is still 6. So doing the arithmetic inside the square root, we have square root of 1 minus 12 times 2 is 24. So we have 1/6 plus or minus the square root of negative 23 over 6. And since we have the square root of a negative number, to make that positive 23, we bring that I out front. And after we do that, we look to see if we can simplify the square root of 23, which we can't because 23 is already prime. So this is your solution for x. There are two of them. One of them is 1/6 plus the square root of 23 over 6i. The other one is 1/6 minus the square root of 23 over 6i. So two complex solutions, and again, what that means graphically is that this parabola with the y-intercept of 2 and an axis of symmetry of 1/6 never crosses the x-axis. That's what getting those imaginary solutions means. And that is the introduction into complex numbers. Tomorrow in class you will be doing some practice with these problems involving complex numbers.